Good morning, good morning. Happy Thursday. It is Thursday already. Wow. I know that every day I go over these problems on the Zoom call, but I find that it might be better for me to go over these solutions, and then that way you can pause or recap them any way you want. So again, uh, again, I'm just going to go over the solutions. I believe the chat room should be working. So if you would like to ask a question, I'd be happy to cover it, but I am just going to show the answers for these. So first I'm going to click on Lesson 3, Student View. Okay, so this is what you see for Lesson 3. Now I wonder if I can use pens on this up here. I do not believe that I can. No, I cannot, unfortunately. But it says here, okay, so it says, describe the function being considered in words. The function shows cans being distributed over different numbers of weeks. By using division, we know there are 180 cans per week being distributed. And the way and you might be thinking, how did you find that out? Well, we used division. We did 180 cans divided by 1 week. That equals 180. We also, you could do 2,160 divided by 12 weeks. That also equals 180. In fact, all of these, I'm just going to write the last one. 8,100 divided by 45 weeks, that also equals 180. And so we found out that there are 180 cans being distributed. So you would submit that answer. It shows, what I would say is, if to describe the function correctly, you just say that there are 180 cans per week being distributed. I should add, the number of cans depends on the number of weeks. Right? Submit answer. Done. There's 16 problems. Let's see if we can knock out all 16 kind of quick. Finish the equation. Well, we did this a number of times. It was 180 cans per week, so 180 cans times the number of weeks. So these are ones that we have seen before, right? Again, y equals 180x. That's how we write the equations. For this one, let's see. There we go. I got my blackboard here. So on my blackboard, where can I put this so that I can show the work? I can maybe shrink it and put it up here. There we go. We want to distribute 20,000 cans of vegetables. So for this, you did a equation that was 20,000 equals 180, and we don't know how many weeks yet. So 20,000 is equal to 180x. I don't know why I had that window too small. To get rid of the coefficient of 180, you divide by 180. And I do believe we ended up getting x equals 111.1 weeks. So we just rounded to 111 because they said to round to the nearest whole number. So 111 weeks. And we did that. Then they talked about the manager. He forgot that they had distributed 35,000 cans on January 1st. So we're going to change our equation. You know how our equation used to be the total number of cans is equal to 180 times the number of weeks? Well, that's going to be part of our total, but also 35,000 is also part of our total. I wonder why this camera looks so... Man, I gotta write smaller or something for this. There we go. I think I will write smaller for this. Is that good? I think that's good. So that's what the new equation is. And so you had to enter 180x, because that's part of the total, as well as 35,000. 180x plus 35,000. Correct. Next one says, use this function to determine how long it will take to to hand out 80,000 cans. So I'm going to show the work. So instead of Y, which is the total number of cans, I'm going to write 80,000. So 80,000 is equal to 180 cans per week plus the 35,000 we already had, right? So we have this equation. And now we're going to want to, dotted line down the middle, now we want to get x by itself. So go ahead and, we did this already, but again, to get x by itself, I will just, I'll do this again. That's okay with me. I believe this was 45,000 is equal to 180x, and then these were canceled. Then if you divide each side, you want to get rid of that coefficient next to the x. So divide by it, and you shall get x equals, let's see, 45,000 divided by 180 cans per week. That says 250. So that means that to get these 80,000 cans from up here, it's going to take 250 weeks. 250 weeks. 250 weeks, but they ask, hey, what is this in years? So I'm going to put this on the side here. Well, as long as you know that there are 52 weeks in a year, we're going to see how many times 52 can fit into this big number of weeks. So 250 divided by 52. I got a total of about 4.8 years. Okay, so 4.8 years. So I'm going to go back to this question and I'm going to say 4.8 years. Notice we started with the function, and with the function that we started with, we then put the given information into the blank. And once we solve that equation, it helps us get how long would it take us to do that? It would take 4.8 years to do that. That seems like quite a long time. It says here, describe the function in this equation. Describe the function here. So let me fix my window because it doesn't. There we go. Let me fix both windows. A linear function has the table of values below, and it shows the distance over time. So describe the function happening in this problem. Well, we know a plane is flying, and I'm going to do just a quick division. I'm going to do 1,700 miles divided by 4 hours. And I believe yesterday we got 450 when we did this division. 425. I apologize. 425. So 425 miles per hour. And so I'm going to type out my answer here. Here I would type, this function shows, and I'm going to say it even more detailed now. This function shows that distance is a function of how many hours traveled. So it says this function shows that distance a plane travels is a function of how many hours it travels. So that means that the input is the hours and the output is the total distance. This airplane travels at a rate of 425 miles per 1 hour. I'm just going to write per 1 hour. Yeah, I could write per hour, but per 1 hour is extra exact. Okay? So all we had to do was do division, and then we just had to say this sentence. This function shows that a plane travels, shows that the distance a plane travels is a function, or depends on how many hours it traveled. Okay? Did I hit go live? I did hit go live. I was scared for a second. Okay. I was worried that I had not hit go live. That would have been bad. Next problem, they say to write an equation. Well, we already know the speed of the plane. It's 425 miles per hour. So that means that the full equation is y equals 425 miles per hour times the number of hours, x. So if it's, yeah, that's how we've been doing it. We take the speed and then we put a variable in front of it. Okay? Then this is another one where we have to answer the question. Assume that the plane is making a trip from New York to Los Angeles, and the journey is 2,475 miles. Let's see how long it would take us to get to Los Angeles. Well, let's write the equation. Y, so the total distance is equal to 425 times x, right? And in this case, the journey of 2,475 miles, that's going to be the value of y. So put in that number in place of y. And then we're going to divide both sides by this coefficient so that we can get rid of it. So divide by 425 on each side. And if my math is correct, this will be, I don't know, I can't do this one mentally. 2,475 divided by 425. I got like approximately 5.8. I didn't get exactly 5.8. My calculator showed me a bunch of decimals, but I just rounded. There we go. So I just rounded. Okay? So 5.8 hours. I'm going to go ahead and go back to my answer, and I'm going to enter 5.8. Correct. Next problem. If the airplane flies for 8 hours, what's the distance it will travel? So for this one, if it 8 hours, x represents hours, and so I'm going to do 425 miles per hour for 8 hours, which means I'm going to multiply by 8. And this I thought I could do mentally, and I probably can, but I want you to also get in the habit of doing this. I can do this. It's just doubling it 3 times. So 850, 1,700, 3,400. So 3,400 miles is how long we would travel in 8 hours. Amazing. Describe in words the function given. So let's look at the function. The linear function has the table of values below. So let's look at this table of values that you cannot see very well. There you go. And let me just close that. It says a linear function has the table of values below. It gives the number of miles a car travels over a given number of hours. So again, we're going to do division. So I'm going to take 232 miles and divide it by 4. So from this table, I calculated that the speed of the car is 58 miles per 1 hour. So what we're going to do is we're going to type in our answer now. It says describe in words the function given. In this function, the distance traveled is a function of the number of hours traveled. When we say something is a function of something else, it means it depends on that other thing. So the distance traveled depends on the number of hours traveled. The car is traveling at a rate of 58 miles per 1 hour. There we go. So we described the function. We described the situation that is happening. And we also made sure to point out that the distance traveled is a function of how many hours you traveled. So when something is a function of something else, it means it depends on that other thing. Okay? Once again, we just found out, we just found out that the speed of the car through division was 58 miles per hour. I did the division, 232 divided by 4 equals 58, and I'll show you that on my board in a second. So I did that division that you are seeing now, and I got a rate of 58 miles per hour. So now the equation, the full equation is going to be y equals 58 miles per hour times the number of hours, x. So y equals 58x. So you see, once you find the speed, the answer is super easy. All you have to do is just put an x in front of it. So it says here, assume that a person driving the car is going on a road trip to a location 500 miles from her starting point. How long will it take the person to get to the destination? So this is the equation we start with. Y equals 58x. Now, when you're reaching a location from your starting point, those 500 miles, 500 miles is represented by the variable y. Because remember, x represents the number of hours, y represents the number of miles. So we rewrite the equation 500 equals 58x. Okay? And now we all know what to do to get x by itself. Hopefully you know to divide each side by 58. And I get approximately, I should have been using these a lot more, 8.6 hours, I believe was the time, right? So I got 8.6 hours. They say don't write the word hours in your answer. Okay, just 8.6 then. Okay? Oh, you guys didn't even see the answer. There it is. I put 8.6 as my answer. Okay? Perfect. I am going to continue. I'm on problem 12 now. This is the question somebody asked me yesterday. What is the equation that describes the function? So, to me, this is actually very, I like this problem. I already know what the equation is, but so check this out. Look at this table of values that I'm about to show you right here. We need to figure out what's the connection between the input number and the output number. So what do you do to the input number to get the output number? Well, at first I thought it was just add 5, because here 2 plus 5 makes 7. But then 3 plus 5 doesn't make 10, and 11 plus 5 doesn't make 34. So we need to come up with a new rule. And there's a couple ways we can do this. All right? Here's what I want to do. Let me just rewrite this table. 2, so x, y. 2, 7. 3, 10. And I'm just going to start there. Because if you have this info right here, you can actually continue the pattern and see that should help you out to continue the pattern. So on the x row, we're counting by ones, right? 2, 3, 4. Maybe I'll put a 1 there. So we have 1, 2, 3, 4. So we're counting by ones here. And every time we count by 1 here, how much are we counting by on the y's? Well, it looks like on the y's we're increasing by 3. So I'm going to fill in the blanks like such. And in fact, let me make sure that you guys can see my full table of values. So check out what I've done. We only had 2, 3, 7, 10 at the beginning, but now I'm adding new numbers because I'm counting by ones up here. I'm just following the pattern that already existed. And then down here we're counting by 3s, so I'm following the pattern that already existed, right? Okay. Now we're going to learn how to basically find the rest of the numbers, okay? So here's how we're going to do it. This is a linear equation, so it always has to start with y equals, okay? And this is where slope and y-intercept come into play, because we are going to do y equals mx plus b. And so from this table of values that we just kind of added some numbers to that, let's find out what is the slope. So remember, to find the slope, m, you have to do the rise over run. So rise over run. And my rise over run is going to be, well, we're rising by 3s and we're running by 1s. So I have easily found my slope to be 3 over 1. Just from the graph, just from the table, I mean. And then the letter B represents the y-intercept. And the y-intercept is on this table. It is this point right here. It's the first point, 0, 1. That's the y-intercept, is 1. And so our full equation, I should probably do this. Can I do that? Can I tilt it a little bit? Yeah, so now I can just write the rest of the equation. Y equals 3 over 1x plus 1. Okay? So all I did was I took a look at my table of values, which is the one you have in your problem. And then I filled in a couple of blanks just based off the pattern that there already exists. So between 2 and 3, I counted by ones, so I just kept counting by ones on the rest of them. And then I kept counting by threes over here. Now that we have the equation, well, first of all, they ask us that. So 3 over 1x plus 1. So let me enter that equation real quick so that you can see that I'm actually doing this. So 3, I'm not going to do 3 over 1x. I'm just going to do 3x because that means the same thing, right? 3 over 1, same thing as 3. 3x plus 1. Submit the answer, and it is correct. I think they're going to ask us to insert a table. So this is how we're going to do it. I want you guys to see this because some people were having trouble knowing how to insert a table here. So a table has an XY table has 2 columns, so I'm going to go ahead and insert table, and I'm going to insert, I'll just do a 10 by 2. So X, Y, and then I'm going to do my values 0, 1, 2, 3, 4, 5, 6, 7, 8, and actually they say to complete the table, so it's got to be 2, 3, 8, 11, 15, 20, 23. Dang, hold on. 2, 3, I got to redo these numbers. Well, you know what? I'm going to do this one right here because this one will make more sense to people, okay? So 0 had a 1 value that went with it. You guys hopefully should be able to see that up there. And I'm going to put my table of values right there. So I'm just copying the table of values that I filled in earlier. 0, 1, 1, 4, and now we're just counting by threes, right? 7, 10, 13, 16, 19, 22, 25. I believe I counted correctly there. Did I? Yep. And if you wanted to find out what some bigger numbers were, you would take the x input and you would put it into the formula. But if you just did this, you completed the table, that's fine with me, actually. And then I would say in this table, the x's are counted by ones, or by 1, and the y's are counted by 3. So I would say that's a good description, and that's filling in the table. So this as long as you have a table and maybe a short description, that would be full points for you. And next problem. Then it says to write the equation for this one. So this one's a new problem. Let me make sure you can see it. So we have a table of values that I'm going to copy. X and Y. And we get 0, 6, 5, 11, 8, 14. I'm just gonna leave these for right now because you already see the whole table there. So you already see the full table that I have up there, right? And I want you to, right underneath that table or right on a blank piece of paper, you're always, whenever you have an equation, a linear equation, you write y equals mx plus b, just like the last problem. And we're going to find out what is the value of b and what is the value of m. All right? So this is how we're going to calculate the slope. Hopefully I have enough room here. So the slope is calculated like this. Rise over run. So I want you to tell me, how much are the y's rising by? In fact, don't use multiple squares. Just go from 6 to 11, how much did that rise by? So if you're at home and you're watching this video, you're thinking from 6 to 11, that's a rise of 5. And then you look at the x values right above those, and you see how much did that run by? And so that is also a 5. So you get slope, m, equals 5 over 5. And 5 over 5 just equals 1. So that means that the first part of our equation is y equals 1x. All right? Next part of our equation is the y-intercept. The y-intercept is b. So if you look at this here y-intercept 0, 6, you know the value of the y-intercept, so that's going to be 6. So your full equation is y equals 1x plus 6. I wonder if if I type in 1x plus 6, I wonder if it'll say it's wrong or if it'll say it's right, because maybe it just wants x plus 6. But we shall see. I'm going to show you what I input. I put 1x plus 6. Submit answer. Oh, counted it right. Awesome. Then it says to insert a table for this function. So I'm just going to copy down the table that I have. So insert table, insert table. And once again, I'm going to do a 2-row table. One row is x, one row is y, and 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to do the numbers 0 through 8 for the inputs. And since the slope is 1, we know we're also counting by 1 on the y value. So 0, 6. So I'm going to put 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, obviously, I filled out this table by looking at the pattern of what they're counting by on the table and then calculating the slope. But you can also use this formula that we wrote out, this formula that says 1x plus 6. You can put in whatever value of x you want in there, and it'll give you some correct value of y, okay? So if you insert this table, that should be enough, all right? If you want to put a description about how much the x is, I'll write that down. I'm going to write down the equation of this graph is y equals 1x plus 6. There we go. So I think that's a good enough description. And we've finished the assignment. Hooray. So that was lesson 3 for 8th grade. Now I'm going to go to lesson 4 and click Student View. This one I think has fewer problems. Okay, 19, geez, I did assign a lot of them. I'm so sorry about that. That's like overkill. Oh my goodness. It's okay though. I would say, as long as, I would prefer that you understand how to do this. You don't have to finish all the problems. If it's not all 19 problems finished when you turn it in, that's fine. But I would like to see quality, good effort answers before that. Again, if we're going to write this equation here, they give us a table of values. Once again, we're going to use division to find the rate of dollars per gallon in this problem. So if you do 1971 divided by 5.4, that's going to give you a rate of dollars per gallon. All right, let's see what rate we get. $19.71 divided by 5, you get $3.94 per gallon. So $3.94 per gallon. Okay? So that means that the equation is going to be y equals the rate times however long you're doing it. So times x. So the equation of this table right here that tells you the price of gasoline is going to be y equals 3.94x. Okay? Huh. I wonder why it did that. 21.9 divided by 6. Oh! Did I type something in wrong the first time? I did type something in the first time wrong. I don't know why I got 394. It's 365. I think I must have input the wrong number or something. 365 per gallon. I have no idea where I got 394. Let me hit up. Maybe I'll see where I got it. 1971 to because I did divided by 5, not 5.4. There we go. My mistake. Are there any restrictions on the values that x and y can adopt? And I'm going to write, just like we said yesterday, I'm going to write, since x represents the number of gallons, the only numbers that make sense would be 0 or more. Because you can only buy 0. I'll write that down. Because you can only buy 0 or more gallons of gas. And then I'm going to write, since y represents total cost, the only numbers that would make sense would be 0 or more, because if you are buying gasoline, that is how much you would pay. You would pay $0 or more, but you wouldn't pay negative dollars for gasoline. So I wrote, since x represents the number of gallons, the only number that would make sense would be 0 or more. You can't have negative gallons. And then same thing with cost, 0 or more. So that's what I decided to answer on mine. I'm going to go ahead and submit answer. Next problem. Is the function discrete? Now remember, discrete means that you're only counting using whole numbers, and continuous means that you're counting using decimal numbers and everything else. So in this function, if I look at the table, the number of gallons and the dollars, that's not just whole numbers. That's going to be like decimal numbers. And so you can actually, this one's going to, is this discrete? No, because discrete is only counting by whole numbers. Okay? What number does the linear function assign to 20? Which means if you look at this gasoline price function and you purchase 20 gallons of gasoline, how much would the total cost be? So you would do $3.65 times 20, which I believe would be $73. So that's what we answered yesterday. $73 for the cost of 20 gallons. Okay? Explain what your answer means. This means that if 20 gallons, let me see if you can still see my answer. Yeah. This means that if 20 gallons of gasoline were purchased, it would cost $73. That's what that means. Cool. Oh, this is the cool function we talked about in the class. So once again, since you're not here to participate, I'm just going to tell you what this was if you didn't realize it. The input is a word and the output is a number. Now the connection we discovered yesterday was however many letters this word has, that's what the output is. So that's what we're going to describe. So describe the function. The function has written words as the input and the number of letters in that word as the output. I think that's about it, right? The function has written words as the input and the number of letters in that word as the output. That's a pretty good description. We're saying what happened. It takes words and it gives you a number. What number would the function assign to the word 11? So we're going to say the word 11 has 6 letters, so the output of the so the output would be, I'm going to say the output assigned to 11 would be 6. Boom. Let's see here. The table shows distances covered over certain counts of hours traveled by a driver driving a car at a constant speed. So they say to write an equation. So to write an equation, you need the speed. And to calculate the speed, you use your table of values. You take distance divided by time. So I'm going to take the one that looks easiest. I'm going to say 235 miles divided by 5 hours. And this one's easy because I know that 5 fits into 120 times. So it fits into 240 times. So it fits into, and then 7 more times to fit into 35. So I believe if you divide that, correct me if I'm wrong, 47. So you get that the rate is 47 miles per hour of this car. So the equation is going to be y equals 47 miles per hour times hours. So 47x is the blank. Okay? Are there any restrictions that they can adopt? So are there any restrictions? So let's see, x represents hours and y represents miles driven. So I'm going to write, since x represents hours driven, the only numbers that would make sense would be 0 or more. Because you can't drive a negative amount of time. Once you start driving, you're at time 0. You're at time 0 right when you start driving, but you can't go back in time. So that's why I wrote time should be 0 or more. Then I'm going to write, since y represents distance traveled over time, since y represents distance traveled in this time, the only numbers that make sense would be 0 or more, yet again, right? Because you can't travel negative distance. Some people say, well, what if you go backwards? Is that negative distance? It's still distance. You're still traveling in a certain direction. And also, if you're driving a car, we're always talking about how far we're going. We usually don't use negative numbers when we're talking about how far a car drives. Is the function discrete? So does this function, is it only, so we only see whole numbers here, but if you're driving a car and time is going by, can you have a decimal amount of time or a decimal amount of miles? The answer to that is yes, because you're continually driving. It's not like you're counting one by one items, right? So is the function discrete? No, it is not. What number does the function assign to 8? Meaning if we drove for 8 hours, what output would be assigned? So for this, you need to use a calculator. You would do 47 times 8. And let me just delete everything else. 47 times 8 hours. And I got 376. So that means that in 8 hours, you would travel 376 miles. So 376, and that's the number. It's probably going to ask what the answer means. And this pretty easy. All functions tell a story. So this means that if one instead of someone, that means that if one travels for 8 hours, the distance traveled would be, what was it? 370. What did I write down? 376? 376 miles. Boom. So, again, functions can be numbers, but it's also a story that is being told. So it's good that you're able to explain that. Now they're asking, how long would it take to drive 500 miles? Now, again, I could write this with the equation, because some people like doing the equation, like 500 miles is equal to 47x. Some other people like to say, oh, I'm traveling at 47 miles per hour. Well, I would just do 500 divided by 47. Well, whichever way you do it, you're doing the same exact thing. Because if you get x by itself, you're doing the same math steps. So 500 miles divided by 47 miles per hour leaves us with approximately 10.6 hours. So so how long would it take to travel 500 miles? 10.6 hours. That's if you're traveling at a slow speed of 47 miles per hour, which this person in the problem is. So for this one, I hope you read the problem. So it says, here's a table that shows the time and the temperature. And then at the very bottom it says, verify that the data satisfies this linear equation. So I'm going to write the linear equation down here because that's the most important part of the problem. Y equals 92 minus 1.5x. Now, to verify, what they mean by that is they want you to put in the input numbers and make sure that you get the correct output numbers. So the input number for 12 noon, well, we said how many hours past noon is 12 noon? And yesterday we said that that was 0. So what we have to do is y equals 92 minus 1.5 times 0. And then if you do that math, you get 92, right? And so what I want you to do is we're going to do that with every single time after that. So for example, now 1 hour later, 92 minus 1.5, I believe that equals 90.5. And yeah, that's what it says up there. So what we're doing is, let me just paste a couple of these. What you're doing is you're going to go through this equation and you're going to input 2 hours. You're going to input 4 hours. You're going to input 8 hours. And you're going to make sure that the numbers are correct. And so 89, 86, and 80. If you do this, I will mark it correct. But you got to make sure that you're using a calculator to make sure that these equations are correct. Okay? Once you do that, you say, I have checked. Actually, I'm not even going to say checked. I have tested all the inputs, and all of them gave the correct output from the table. So we just verified that the formula works. Are there any restrictions on the values that x and y can adopt? And yesterday we said since x represents hours past noon, we decided that only numbers 0 through 12 made sense. Otherwise, we go into the next day and the formula does not work anymore. And the reason the formula does not work anymore is because the formula shows it's dropping 1.5 degrees per hour. And that's not going to happen forever. The temperature's only going to drop so much, and then it's going to go back up. So only 0 through 12 would make sense. And then we said, since y represents temperature, and this function is decreasing. By the way, this is decreasing because it says minus 1.5x. And since this function is decreasing, only temperatures 92 and below make sense. Yesterday we even said 92 through like 74. We got really specific, but I'm just going to say the only numbers that this can take on is 92 and below, because, that would make sense there. Okay. Is the function discrete? So if we look at this, are Are we allowed to only use whole numbers when we are measuring time and temperature, or are we allowed to use decimals? If you're allowed to use decimals, then that's continuous. So is the function discrete? No. We're allowed to use way more than just whole numbers. So I'm going to click no. Correct. According to the function of part A, what temperature will it be at 5:30 p.m.? So let's use the formula. So remember, the formula was temperature equals 92 degrees minus 1.5 times, what'd they say, 5. Well, 5:30 is 5.5 hours past noon, so I'm going to do that. So if you take this formula and you input 5.5, you should get 92 minus 1.5 times 5.5. I got 83.75. 83.75. So it should be 83.75 degrees. Is it reasonable to assume that this linear function could be used to predict the temperature for 10 a.m. the following day, or a temperature at any time next week? Again, if we go too far, if we have too many hours, the formula is showing that the temperature is dropping by 1.5 degrees each hour. But that's only going to happen during the day, like from noon till night. That will happen. But after midnight, the temperature starts going up again. So the formula would not be able to help us out in predicting that temperature. So if we go too far, like into the next day or the next week, no, that would not be reasonable to assume. And give specific examples. And I'm going to say it would not be reasonable to assume this formula could predict the temperature tomorrow. It would not be reasonable because temperatures go up and down each day, not just down like the formula indicates. That's one example. Like I just wanted to say, in this formula, the temperature is going down each hour by 1.5 degrees. So, but that's not how real life works. So formulas can help us predict real life situations only sometimes. They only have limited power. Like a linear equation is not going to help us predict the future of temperatures, but it might help us predict how the temperature might work during the day, during that same day. And that's the 8th grade assignment. So I will be back in a little bit. I'm kind of mathed out, so I'm going to come back and I will do the 7th grade solutions in a little bit. Okay? Thank you, and tune in later. Bye. Actually, no, I'm going to edit the title here because I'm going to change it to 8th grade. There you go. And end stream.